Now you will see a simple example where you write Systemverilog assertions to check the states of a state machine. So here is a simple state machine. Assume that it got only two states, an idle state and a read state, and the FUB got an input which is named as data valid and output which is read valid. So whenever the data valid signal is high, the state machine will change its state from idle to read. Whenever data valid is deasserted, the state will go back to idle state. And if the state machine is in read idle state, the output read valid will be 0, and if it is in read state, the output read valid will be high. Also assume that as long as the state machine is in the idle state, the read valid will be always 0, and when the as long as the state machine in the read state, the read valid will be kept on high on every clock cycle. Now we will see how to write Systemverilog assertion for this state machine. So here are few properties defined for this state machine transitions. So it's quite simple. We are using both same cycle implication and next cycle implication operators. So it's very simple. The first property is defining as at positive edge of clock, if the state is idle, then in the same clock cycle, the read value should be equal to 0. So when the state is in idle, the output read value should be equal to 0. And in the same way, if the state is read, in the same cycle, the read value should be equal to 1. So these two properties are using the same cycle implication operators. And the next two cycle properties are using the next cycle implication operators. So whenever the state machine is in idle and the data valid is asserted, the state should go from idle to read. So it is written as like at positive clock, if state is equal to idle and data valid, in the next cycle, the state should be equal to read. In the same way, if the state is in read state and if data valid is going low, in the next cycle, the state should go idle, which is written in this statement, which is covering this transition. And the next statement, the next property is defining this particular scenario criteria. So the state is in idle, and if there is no data valid is changing, then the next cycle as well the state should be in idle. So the state is in idle, and if data valid is not asserted, then the state should be kept on the same state as idle in the next cycle. And in the same way, if the state is in read and the data valid is not going back to 0, then the state should be kept on in the same state as read. So this is a very simple example of using cycle implication operators to define properties. And you will use this same cycle implication and next cycle implication operators more frequently when you use sequences, which you will learn in the coming sessions.